Okay, this is going to be a really quick recap of what we did with our step functions. And first I want to show you the two different functions. So we have our floor function and we have our ceiling function. The floor is thought of as the round down, and the ceiling is thought of as our round up. And you definitely want to think about the number line because it gets kind of confusing for negative numbers. So I'll do a couple of examples here. Before I do that, though, I want to remind you that the floor function is sometimes presented like this, or maybe even with double lines like this. You'll see it like that. So be very careful that you know which function you're actually dealing with. So if I have a function and I need to apply the floor function to 3.5. That just means round down. So I would get a 3. If I have a negative 3.5, the next lower integer is not actually a negative 3. It's actually a negative 4. So that's what I'm talking about with that function. So be careful there. And with the round up function, if I have a 3.5, it would round up to 4, and if I have a round up for negative 3.5, it will actually round up to negative 3 because negative 3 is to the right of negative 3.5. So that's how you evaluate using the two different functions. And also graphically, I just want to kind of show you the difference between the two graphs. This would just be the parent function floor, and you always start at the origin with 0, 0 with a closed-in bubble, and you open to the right at 1, 0. Okay, then you go up, open to the right, up, open to the right, up, open to the right, and then of course you do the same thing down below. You notice there are vertical lines that have both a closed and an open circle, and then you continue on with that pattern. Now, the only difference is that for the round up function, graphically, make sure you all can see this, you still start at 0, 0 with a closed-in hole. But now you go to the left to put your open circle. And you still have a vertical line that has both a closed and an open. So go in the other direction. Now, I want you to notice that on both graphs, you have points that like 0, 0, 1, 1, 2, 2, 3, 3. Same thing over here, 0, 0, 1, 1, 2, 2, 3, 3. And it's because when you evaluate whole numbers for either function, it remains the same value. So just for example, if I have f of x is equal to 3, it equals 3 for the round down. And if I evaluate it here for 3, it equals 3 for the round up. So that's what creates that effect. In application, we're going to really be doing more with the graphing, and really we're going to be doing a lot more with the floor function anyway, but we have to introduce the ceiling function as well. So let's look at this example I have here. So what I want to do is I want to translate this to 2, 1. So I'm going to go to 2, 1, and I'm going to put a bubble in place. I know that it is the floor function because of the symbol, so that means my open circle is to the right, just because of how the rounding works. Okay, so go ahead and put that in place. And this will always be a length of 1 here, unless there is a horizontal stretch or compression, and that would be something put inside with the x that would achieve that. Now, the negative 3 is both going to reflect it because of the negative, and then it's also going to stretch it, meaning I'm going to jump or step by 3s. So I'm going to go up 1, 2, 3, and I'm going to actually put an open hole because I have to go back to the left for this to make it have a slope basically like negative 3. So if you want to think of it like this, you would go down 3 to the right 1 to get to the next point. That is creating a negative slope. and it is actually a slope of 3 if you consider the relationship between those 2 points. Really, you're just gonna go down 3, 1, 2, 3 to put the next value in place and continue in that pattern. So 1, 2, 3 down here. Now, the domain for these will always be negative infinity and infinity. The range here is kind of weird because it goes from -5 to -2 to 1 to 4. So I have a mixture of odds and even numbers. So what I'm going to do is I'm going to say dot, 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 and I'm going to start with -5, then do -2, then 1, then 4, dot, 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 in that pattern, okay? The x-intercept here is there, none. The y-intercept would actually be, I'd have to keep going up, let's see, 1, 2, 3 would put me at 7, so I have an open hole at 7. So it's actually going to be at 0, 7. So that would be the y-intercept. Is this even, odd, or neither? These are always neither, okay? So that is what the function looks like. Remember, the floor function has a closed-in circle with the open to the right. The ceiling function is exactly the opposite. So I'm going to translate here to -1, -4. So -1, -4, and I'm going to go down and put my closed hole in place. Remember, this opens to the left, so go to the left by 1. This has like a slope of 2 almost, but I'm going to be skipping steps. So I'm going to go up 2 to put my next hole, just carrying on the pattern like this. Okay, so the domain is everything as I've mentioned. The range here is going to be -4, -2, 0, 2, 4. So it's all even integers because it's jumping by 2's and it's happened to start on an even. The x-intercept is an interval here between 0 and 1. But remember, it does not include 0, but it does include 1. You have to look at where the solution is inclusive. Here it is at 1, not at 0. The y-intercept is going to be 0, -2. Not 0, 0, but 0, -2. And again, this is a neither function. So that's a real quick recap of what we've done kind of for the past 2 days in case you need to look at that. And we will pick up with some new information tomorrow. Y'all have a great day.